All right, we got a pretty interesting integral here today. Today we have the integral of hyperbolic secant of x. Now, hyperbolic trig is not a thing most people are familiar with. However, it's still a thing that's out there in the world of math, and it does have a lot of the same properties that normal trig does. For example, in normal trig, we know that secant equals, or secant of x, I'll say, equals 1 over cosine of x. And this is the exact same thing for hyperbolic trig. It's just going to have this extra h here. So I'm going to rewrite that integral. I'm going to rewrite hyperbolic secant as 1 over hyperbolic cosine of x. For one thing, it'll make it easier to work with, and for another, it's actually easier to say. I don't have to say hyperbolic cosine. It's actually pronounced cosh. So, cosh of x actually equals something in terms of exponential functions. Cosh of x is equal to e to the x plus e to the negative x, all divided by 2. I'm not exactly sure where this formula comes from, but it's out there somewhere, came from somewhere, and it actually helps us out a lot in our integral. So I'm going to plug in this whole junk of mess, whatever this is, in for hyperbolic cosine, for cosh. So in doing that, we will get 1 over e to the x plus e to the negative x, all over 2, and then dx. And now this is the same as 1 over 1/2 if we're just considering this 2 in the denominator of the denominator, I guess, whatever. So this is actually just going to simplify to a 2 in the numerator. And so I'm going to pull that constant out. So doing that, we're going to be left with 2 times the integral of 1 over e to the x plus e to the negative x dx. And now I really don't like having this e to the negative x in the denominator. It makes the whole integral hard to work with. So to fix that, I'm going to multiply both the numerator and denominator by e to the x. It's the same as multiplying by 1, but it actually helps us out a lot in solving. So 1 times e to the x is just going to give us e to the x in the numerator. And for the denominator, this is separated by addition, these two terms, so we're actually going to have to distribute our e to the x into both of these. So first, e to the x times e to the x will give us e to the x all squared. And then e to the negative x times e to the x is just going to give us 1. So our integral has now changed to, so we still have this 2 up front. On the inside, we have e to the x over e to the x squared plus 1. And now it might be a lot easier to see what to do here now. We're going to do a u substitution. U equals e to the x, or du equals e to the x dx. And this is really nice because we have an e to the x dx right here. And then we just have an e to the x right here. So, if we plug in our substitution, we're going to be left with 2 times the integral of du over u squared plus 1. And this is really nice because this is just a formula, essentially, that we know. And so this is just going to give us 2 times arctangent of u. And lastly, we can back substitute. U equals e to the x. So our final answer will be 2 times arctangent of e to the x. And don't forget, we still have a plus c. And that is our final answer.